This problem states that there's a 10-gallon rigid tank containing saturated propane vapor at 20 degrees Celsius, and then due to heat transfer in the tank, the temperature increases to 40 degrees Celsius. And it wants us to determine the change in pressure, stored energy, entropy, and stored exergy. And then it gives us some atmospheric conditions. So it's pretty obvious that we want to use the PC model since it tells us that it's a saturated vapor, so it's right on the verge of a phase change. Alright, and we'll change that to propane. State 1 we were given as 20 degrees C. It told us it's saturated vapor, which means the quality is 1. And we know the volume is 10 gallons. Calculate. And then since we are going to be calculating the change in stored exergy, we're going to want to do a dead state, which is state 0. It's usually just atmospheric conditions. It's kind of like the equilibrium state. So we were given that that's 100 kPa and 25 degrees C. Hit calculate. And you can see that phi is 0, and that's the specific exergy. Alright, and now there's a phi in state 1, which there wasn't before. Alright, state 2, we know that temperature is now 40 degrees C. We know that the volume is the same. And we know that the mass is the same because it's a closed system. Alright, and we hit calculate. And we have all of our values. So now we can go to the I/O panel and calculate all of our values that were asked of us, which were the change in pressure. So I'm just going to choose dP for that, equals P2 minus P1. I just hit enter, and you can see right there 79.9 kPa. Also the change in stored energy, which is E. It gives us in the states specific stored energy, so we're going to have to multiply that by M. Either M, it doesn't matter since they're the same. I just chose M1. So times E2 minus E1. Enter. There we go. 22.3 kilojoules. And then change in entropy. M1 times S2 minus S1, enter, and then change in stored exergy, which is phi. Right, and so dphi we get 1.11 kilojoules. Now the problem asks to repeat the same problem, but instead treating the propane as a perfect gas, ideal gas, and then a real gas. So the easiest way to do this is to hit super calculate in the PC model, which loads the test code. And then you can just copy this, copy it, and then we'll start with the PG model for perfect gas. And just go in the I/O panel, paste that code, hit load, hit super calculate, and then calculate. And you'll see down here it says there's errors. And that's because if you go to the state panels, there was obviously some errors in state 1 and state 2 loading. That's because in the PC model we entered a quality, X1. But in the PG model, there is nowhere to enter quality because gases don't have a quality. So we're going to have to kind of re-enter states 1 and 2. So that was 20 degrees C, 10 gallons. And since we don't have anywhere to put quality, just in the PC model, it was calculated that the pressure for state 1 was 28.5 kPa, so we'll just enter that and hit calculate. Alright, And then state 2, it was 40 degrees C. Same thing, volume equals volume 1. And closed system, so equals M1. Alright, calculate, and I'm going to hit super calculate again. And then calculate again. And there's our answers down here in the output area. And you can see they're different. Before we got a pressure change of about 80 kPa, so that dropped pretty drastically. Before we had a change in stored energy of about 22, a change in entropy of about 0.07, and a change in stored exergy of about 1.1. So it is pretty different. Saturated vapor is not a gas, so that's why they're pretty different. You should definitely use the PC model for this, but we're going to do this problem anyways. So now, since we're going to do the IG model, that's also a gas model, we can just copy this code and enter that into the IG model, and it should work without having to enter anything else. So paste that in, load, super calculate, and then calculate. And there's our answers. So we get about 56 kPa pressure change, 18 kilojoules for the stored energy change, 0.06 for the change in entropy, and 0.3 for the change in stored exergy. So that's pretty similar to the PG model, but a little different. And they're both pretty far from the PC model. Right? And then again, we'll just paste that same code into the RG model. You could also just redo the whole thing in this, but you're going to have to start with the PC model because you need to find that pressure. It doesn't give you enough information in the original problem to do this without finding that pressure first. Right, load, super calculate, and calculate. And there we go, about 70 kPa change in pressure, 21 kilojoules for stored energy, 0.07 for entropy, and 1.3 for change in stored exergy.